Hello friends, in this session I'll be going over some typical problems or error situations which can come up especially on heavily loaded OpenStack compute nodes and network nodes, even the controller node also. So as you can see, this is one of our compute nodes and it has more than 200 active virtual machines loaded on it. And during the progression of building up the load, we have seen certain problems which I like to provide you details about so that you can be better prepared for them if they come up on your systems. So the very first problem I'm talking about is MySQL limits. Once you reach around 100 virtual machines on a single compute node, even on the controller also, you will see MySQL limits errors coming up. So the solution for that is to set the global max connections to 250,000 or more than that, and then that problem will go away. Next problem you will see is MySQL will start erroring out with the error too many open files. So to avoid that, you can set the following two conditions: default limit no file, default limit memlock is equal to infinity in the etc systemd system.conf, and after that systemctl daemon reload and service mysql restart. Then you can go to the mysql and check the value of this particular variable that it is applied correctly. So this is set to a very high level and this will not cause any problems after that. So next issue which we have seen is on a brand new freshly installed system, certain limits and configurations need to be adjusted, especially for Nova. And I'll go over one by one all of these which need to be adjusted to make it operational system. Because you might have seen you're able to create smaller virtual machines with smaller images, but not larger virtual machines using larger images. So I'll bring up the Nova config. One thing to check for is oversubscription ratios. So the CPU allocation ratio should be more than your number of threads available, because you can easily oversubscribe up to 10 and even up to 16 level. That means a single vCPU can translate into 16 vCPUs for your virtual machine. Same goes for RAM allocation ratio also. So you may want to oversubscribe because most of the virtual machines do not use up all the resources, and we can evenly distribute out and easily oversubscribe our system. So the RAM allocation ratio we use is 6. You can utilize it according to your calculations. Same goes for disk allocation ratio also. Most of the virtual machines have 80% of their space available. So if you do disk allocation ratio is equal to 10, you can oversubscribe a 2 terabyte hard drive all the way up to 20 terabyte. And another thing is the block block device allocation retries. So you may want to change it, uncomment this line out, because for smaller instances the default retry level is fine, but for larger instances the retry level should be higher. So you can set this to 60, and another config to change is block device allocate retry interval. Change this to 100 or so. so that your system is capable of waiting till spawning of a larger virtual machine happens. Coming back to our next setup problem is basically once you exceed exactly at your 100th virtual machine, your virtual machine will stop spawning and getting created with the error that unable to allocate port, and port is already in use. That is because the VNC port start from I believe 6900. So let's take a look at that config and what to change it to. So VNC port starting value is, I believe, or default value is 5900, and exactly at 6000 port there is a default, there is a allocation in OpenStack, and it stops at that point and doesn't skip that, but it gets stuck, and you will have to change your VNC port starting value. So we have seen from 7,000 all the way up to 8,000, none of the ports conflict. So if you set the VNC port is equal to starting value as 7,000 and total number of ports at 10,000, you'll be good to go, exceeding the 100 virtual machines limit, which I don't think is, it should have been designed properly, and they should have accounted for available range of ports. Next issue is you might see connectivity loss, especially when you make changes to your IP tables and save it. You will see that their entire networking, neutron networking, stops responding. And so, to handle that, we have created instead of directly restarting IP tables, you put it in a script, you restart IP tables, you restart IP6 tables, and after that you need to restart these three services in this particular sequence only. So Neutron L3 agent, OVS DB server, and Open vSwitch agent. So this will immediately rectify the lost network connectivity, and your network will not get impacted after you make changes to IP tables. This can also be used in other scenarios when your neutron networking somehow is not responding okay, or there are ping issues for your virtual machines. Another complex problem is DHCP failures. At times, due to restarts or other issues, you will see that your DHCP server for your individual networks does not allocate IP addresses. So to handle that, you can check the router namespaces. So if you do IP net, and so this you need to do on your network node, or if your network and compute node is combined on your compute node. As you can see, these are the namespaces for all the DHCP routers. And after that, you can run the next command. You can identify the right DHCP namespace by trial and error, and then with this command you can get the net stat for that namespace. So here you can see if your DHCP is listening on the port 80 or not, and on the right ports, and if needed you can restart your DNS mask utilizing utilizing the service restart commands. Another issue which is related to this is the metadata proxy issue. So if you, for some reason, your metadata proxy is not working and your VNC, your virtual machines are not getting the metadata. Metadata is used for custom init scripts as well as assigning the public key, uh, uh, the RSA keys to your instances. And if that doesn't work, you will end up with a virtual machine which you cannot access because there will be no public key installed for your access. The solution to that is you can do a ps-ef grep metadata proxy, and these are the instances, and you can kill -9 all the PIDs for your metadata proxy, and then with the systemctl restart neutron DHCP agent, you can restart the metadata proxy. This way, you will be able to correct that problem. We have consistently seen that this is a foolproof solution to resolve the metadata proxy issue. Another thing you will notice with the freshly installed system, especially Wallaby on CentOS 8 or Red Hat 8, is that you are not able to upload images to the Swift system, and you get a file permission issue. So this has recently started happening with the latest releases. So I hope this will be fixed later on. But the immediate solution is to do a change mode on the Swift mount point. Swift mount point is on the controller node. As you can see, this is the Swift mount point, and if you do the this particular command to do the right permissions on it, that problem will be resolved. So that's some of the key issues which you will face, and you can, instead of waiting for those issues to happen, you can plan ahead on a fresh installation and apply all these settings. We'll also be providing this script as part of attachments to this course, so you can utilize that for running those commands. Thank you.